Welcome all of you to another video of Maths Made Easy. In this video, I am going to take up only sums based on Ohm's law, that is V is equal to IR. So let's start. So here there is a resistance of 6 ohms connected with another resistance of 4 ohms. Okay, 6 ohms and 4 ohms. And this is connected to a 20 volts. Okay, the potential difference is 20 volts. Okay, potential difference of 20 volts is across the combination. Now here I want to tell something. If I current is flowing in the circuit, then I current will only flow through the 6 ohms and I will also flow through the 4 ohms. This is not same in parallel. Okay, so I flows through this also and this also. Now calculate the current in the circuit if the potential difference across and the potential difference across the 6 ohms resistor. How do we find the current in the circuit? Now here we will take what is the equivalent resistance, that is combination of these two, that is a 10 ohms because R1 plus R2, and V is equal to 20 volts. Therefore V is equal to IR, which is I is we don't know, R is 10 and V is 20. Therefore I is 2 amperes. Now the second thing they have asked us is the potential difference across the 6 volts resistor. Now this is a very important question. Potential difference in series, that is if I put a voltmeter here, this voltmeter and this voltmeter is going to give me, this is V1 and this is V2. They are going to give me different readings and these two on adding should give me 20 volts. This is for a series connection. So each of the resistances have a different voltage potential difference across them. We have to remember this. So here potential difference across which one they want? Across the 6 one. So what we will do is we will apply V is equal to IR only for this portion. Okay, but remember the current is 2 amperes only. So here again V is equal to IR but for the 6 ohms. So V is equal to IR, then V is how much? We are going to find that. Let's write V1, okay, and then R here, let's write R1 also, but I is same throughout. So R and this is I is 2 because as I said I is going to be same throughout, and R is how much? R is 6. They have given R1, so this is a 12 volts. So across this is a 12 volts. You can similarly find for this also, which is going to be, I'll find it and show you, though they have not asked. V2 is I, R2, which is, this is I is 2, R2 is a 4, that makes 8 volts. Now see, 12 volts plus 8 volts, you get your 20 volts. Okay, so 12 volts plus 8 volts gives your 20 volts. Okay, so this is it. Calculate the current flowing through each of the resistors A and B. Okay, now this is the sum where you have to find the current flowing through. Calculate the current through A and B. This is our question. Okay, now where is A and where is B? This is A, this is B. A is 1 ohms and B is 2 ohms, and then we have to, and this is 2 volts. How much of current is flowing through this and how much is flowing through this? Now remember, this is a parallel connection. Junction points are here, means this is where the current starts bifurcating. Okay, it starts splitting. Now they want separately current, how much of current is flowing through this and how much is flowing through this. Okay, so let us find. Now remember one thing. In both parallel and series, we have to remember this separately. The potential difference across this branch and this branch is same in parallel, which is a 2 volt. Okay, so V is equal to IR if I do for the first one. V A. Okay, so V is same. So V is equal to IR. Okay, this is for A. This is for the A one, and that is I. We don't know I. But we know V, which is a 2. We know V, which is a 2. And we also know R, which is a 1. Therefore, I is equal to 2 amperes. That was for A. Okay. Then, for the B part of it, this resistor B. For resistor B, again V is equal to IR. Then V is, we know again it is a 2. I, we don't know, we are finding. And R is a 2. Which is a, so I is a 1 ampere. Okay, so the total current, if they ask, through this 1 ampere is flowing, through this 2 ampere is flowing, and remember the total current that is flowing is 3 ampere. Okay, so this is, you should also know, if they ask supposing what is the total current flowing, it is 3 ampere. So before this we did a sum which had a series connection. In that series connection we had different voltages, different potential difference for the two resistors. In this, in parallel connection, the potential difference is same for both the resistors. Okay. Okay, so this is the sum. Calculate the total resistance of the circuit, the value of R and the current flowing through R. Total resistance of the circuit. First, this is a 20 ohms, this is R ohms, we don't know, they are asking for the value of this. Ammeter reading is a 0.4 amperes. Okay, ammeter reading. Note that the ammeter is connected in series to this parallel, this part is parallel, but after that they have connected it in series. Now here voltmeter reading is a 4 volts. Okay, so we have to find the total resistance of the circuit. Now if the ammeter is showing 0.4 and voltmeter is 4, if I use V is equal to IR, means the total current in the circuit is, if it is written over here, if ammeter is here, means the current which is, here, the current passing through this in the main part of the circuit, not in these branches, is 0.4 ampere. Okay, so and the potential difference in the circuit is 4. So I is 0.4 and R is this. R is 4 by 0.4, which is a 40 by 4, which is a 10 ohms. So the equivalent resistance of the circuit is 10 ohms. Now we have to find the value of R. Now we can actually get the parallel, for this parallel connection we can get the equivalent resistance. Okay, and how much is it? It is 10. So if I write 1 by 10 is equal to 1 by 20 plus 1 by R. Okay, so 1 by R is 1 by 10 minus 1 by 20, which is 20. 2 minus 1, which is 1 by 20. So R is, so I took this value and this is supposed to be actually giving me the equivalent resistance. So I use the formula of equivalent resistance here and I wrote it from the first step only as 1 by 10 because my equivalent resistance I knew was a 10. So here R is a 20 ohms. Second part done. The current through R. Now we have to find the current through R. Now remember, whatever current is coming here is getting split into two parts and not equal parts. The parts depend on the resistance. So here this R is now 20 ohms. Okay, now they are going to come same only because 20 and 20, so equal current is going to flow through them. Still we will do a sum and find it out. So here if I do a work for this, only for this branch, if I try to find V is equal to IR. Okay, V is in parallel connection, V is same for both the branches. So V is a 4, I is a, how much? I don't know, I am going to find, and R is 20. So I is 4 by 20, which is 1 by 5, right, which is 0.2 amperes. Okay, so I comes to a 0.2 amperes. So this is why we should always keep noting whether it is parallel or whether it is in series. Okay. Now here is a question. Now they have given, this is 2 ohms, R ohms in parallel, 4 connected in series. The current flowing through the circuit is the main current is 0.25 amperes, 2 volts battery, and this is the internal resistance of the cell. Now what is the internal resistance of the cell? The internal resistance of the cell is, the cell either will have some dry chemicals or it will have some liquid in it, which is the electrolyte in the cell. Now the internal resistance is that the resistance that the current faces while passing through it. Okay, so the resistance of the material inside the cell, that also gives a lot of resistance to the current. That here is a 3 ohms. Now let me tell you in the beginning only that in this video this is the only sum that I am going to take up with the internal resistance. Later on I am going to post another video in which I am going to take up EMF and internal resistance questions only. Okay, so you will have similar circuit diagrams, but in that internal resistance and EMF and terminal voltage, all these things will be taken in detail. Now here in this, I want to remind you one thing. This internal resistance is always taken in series with a full circuit. That one concept you must remember. Okay, it is in series always with a full circuit. Now what have they asked? The potential difference across the 4 ohms resistor, this. Okay, now here how much is the potential difference? As I said, this will have a different potential difference. This part is connected to this in series. This one will have a different potential difference. Okay, and both will add up to 2 volts. Okay, now here for this 4 ohms one, first let me take the entire equivalent resistance of the circuit. So that how much is this? This is 1 by R dash is 1 by 2 plus 1 by R, which is R plus 2 and here 2R. So R dash, that is for this one, this parallel connection is 2R by R plus 2, right? It is 2R plus R plus 2. With that we'll have to add this resistance, and with that we'll have to add this resistance. When we add all these three, that makes the equivalent resistance of the circuit. Okay, so the total resistance of the circuit is all three added. Okay, so now one thing, since we know the current, which is passing through this part of it, this combination, it is 0.25 only. Total current is 0.25. Okay, so we can actually find the, now we will first try, and we have got the resistance for this. Okay, so let us form an equation, and with the help of which we will get the value of R. So the first part of the equation, we should take this, which is 2R by R plus 2, and then we should take this plus 4 and then plus 3, that is this one. Okay, and that is the equivalent resistance of the circuit. Okay, if that is the equivalent resistance of the circuit, V is equal to IR. With R, we will have to multiply. We'll have to multiply the current in the circuit, which is 0.25 amperes, and that is equal to 2. This is this 2. Okay, the potential difference in the circuit. So here, how much is it? We need to calculate this. Now, what are the things they asked? Potential difference across the 4 ohms resistor. Across this also we need to know. So let us keep this equation ready here, and let us first find potential difference across the 4 ohms resistor. Now how? Because current 0.25 amperes is only flowing through this. So if we want to find how much is the V is equal to IR here. So here current is 0.25 and this here R is 4. Okay, then how much is potential difference? That comes to a 1 volt. Okay, so potential difference across the 4 ohms is a 1 volt. Now if we find the potential difference, the next part of the question is potential difference across the internal resistance of the cell. Potential difference across the internal resistance of the cell. Now remember, this is also in series. Okay, and this 2 volt applies for the full thing. Okay, so how will we find only for the internal resistance of the cell? So first thing is, let us first find the value of R. Okay, once we find the value of R, we can find the rest of the things. So here, this is how much? This is 2R by R plus 2 plus 7, yes, into 1 by 4, 0.25, 1 by 4. So I will make this straight 8, 1 by 4 I multiplied there. So 2R, R plus 2, that is 1. Okay, now 2R is equal to R plus 2. So R is equal to 2 ohms. So we got the value of R first. Now in these sums, these things happen you can't really maintain the sequence all the time. The value of R, that is this, became a 2 ohms. The potential difference across R ohms. Now we have to find the potential difference between these two junction points, whether R or 2, it is the same. So how much is the potential difference across this? That we need to find. So how much is the potential difference across R ohms? Let's find that. Now here the equivalent resistance then becomes how much? First, let us find the resistance of this part of it. Okay, so 2R, R plus 2 is a 4 by, this is 4, okay, which is a 1. This becomes a 1 ohm. Okay, it becomes a 1 ohm for this. Now V is equal to IR, if I apply only for this much part between these two junction points, then V, we are going to find current is 0.25 only, and the equivalent resistance for this is 1. So it is 0.25 volts. The potential difference across these two, that is, if I put a voltmeter over here like this, if I put a voltmeter like this, okay, then it is going to give me 0.25. Okay, now so here I found this one, I found, okay. Now I will have to find the potential difference across this one. I have to, so I found this, I found this, I have to find this, the potential difference across the internal resistance of the cell. Now most of the people will straight away write a 2. Okay, 2 is not the correct answer. Let's see how we find it, because 2 is meant for the entire circuit. 2 is meant for the entire circuit. Okay, so now here potential difference, there can be many ways of finding. One is, here how much had we found? The potential difference across the 4 ohms resistor was a 1 volt. This is a 0.25 volt. Okay, so 1 plus 0.25 plus this 1 plus 0.25 plus this one is how much? This one, let us take it as a V1. Okay, that should make 2 volts. Total means the total potential difference across this plus this plus this is a 2 volts. That is this value. Okay, so V1 is equal to, this is 2 minus 1.25, which is 0.75 volts. So for current to pass through this battery or the cell, it faces a potential difference of 0.75. So what we have to remember is the potential difference across this and even across this all add up to this value, the EMF of the battery. Okay. So that was it in this video. I hope you liked the video. If you have liked the video, do not forget to like, share and subscribe. I'm going to come up with more questions in electricity, specific resistance type. I'm going to come up with the Coulomb and connection, the relation between Coulomb, electricity and time, that kind of sums. Also there are more questions on power. That is a very, very important thing, power of a particular circuit. So you will, and the heat produced and all these questions. So they are going to all come up in different videos. So please subscribe the channel if you haven't subscribed by now. Thanks for watching the video. Bye then.